Good morning, I'm Deanna Pittman.
And I'm Brooke McGowan.
And we're at Varina High School, and this is our Algebra I class.
Welcome.
So today we are combining like terms and we're solving equations. So we just did our number sense routine, and we're going to move on to our activity. Look at that for a second, guys. You know what to do with that?
Yes.
Jaden says yes. What's your first reaction when you see that? That's a lot, Deshaun says.
Right?
Yeah. Complicated, right? Would you want to do that problem right now?
Yeah. Yes.
No.
No? Okay, that's the reaction I wanted. By the end of class, you guys will be able to do this problem, okay? Because we've already been reviewing how to simplify expressions. And if you look at that, that is one giant expression that we practiced last class. And the reason why we learn how to simplify all this stuff is because it makes solving problems, notice how there's an equal sign at the end here. We're going to get into equations today. It makes solving problems like this way, way, way easier. And so, like I said, by the end of class, you guys will be able to do that problem. So, last class, we got to different spots in this activity. You guys notice you have your half sheet back and the little slip of paper again. Some people got set 1 done. Some people got set 2 done. No one got set 3 done. So we have given you a slip to the one that you were at. If you have set 1 and you already have some answered and you're like, no, I got the wrong paper, that's because there's an issue with your answer. Okay, so set 1, if you have something written down and you still have a slip of paper that says set 1, then that means you got something wrong and you're going to go back and redo it. If you have set 2 or set 3, it means you already finished set 1 and you're just going to do the same thing but with set 2 or 3, whichever one you have in front of you. So I'm going to demonstrate with set 1 up here because most people have set 1. But remember, these are all separate terms, okay? And which ones can be combined together? Deshaun?
2 and 4.
Okay. The 2 and 4 what? Those? Those can be added together? Jaden?
2x plus x.
Okay, the x terms, there's a 2x. There's an x down here. No, they're all kind of mixed up though. Wouldn't it be nicer if we could put them all right beside each other? Okay, and so that's what you're going to do, is you're going to take your slip of paper that you have, even if you're on set 2 or set 3, you're going to take your slip of paper and you're going to rip it, okay, in the spots where the terms are separated. Okay. So rip the paper, 2x plus 4, all of those are going to be on different little slips of paper now. Okay. If you're unsure of what we're asking you to do, ask us. Rip them in the spots that we can see up there. They're kind of spaced out. And once you rip them, you're going to sort your terms into the 2 piles that you see. I heard a little bit of confusion about which ones we can combine together. So we'll see what we think is the right grouping. Okay, and so now group your constants together and group your x's together.
We do x.
Yeah, good. Good. Yep, so you've ripped yours up. And I want you to sort these into 2 piles. The ones with the x's and the ones that are constants or don't have an x. Yeah. Good. Okay, and once you sort them into your 2 piles, you can combine them together. So you can add the coefficients together and simplify the expression. If you need a calculator, you can come grab one. Most of these I think we can do in our heads for right now, but you might need one as they get a little more complicated. But on set 1, okay, let's make sure we all see set 1. If you're set 2 or set 3, then you've already done this one. But on set 1, you guys group 2x with what else? Okay, with an x. Okay, 4x, Jaden says.
And then you take away 3x from those two added together.
Okay, and so this can be combined with the others? You guys agree that those are like terms? They all have the exact same variable? Okay, what can we do with like terms? Combine them. So, like Jaden said, he saved that one for the end. I did the same thing. What's 2x plus 4x? 6x. And then we have another one over here? 7x. Good job. And so then take away 3?
4x.
Would be 4x's left. And so on your answer sheet, your half sheet, you can write 4x because all 4 of those things combine together to leave in algebra tiles, that would be 4 green bars left over. Okay. And so then that leaves our other pile. What do we do with,
4 plus 6.
okay, 4 plus 6 is 10.
Plus 3 is 13.
Okay.
Minus 2.
Jaden's got it.
11.
Give everyone else a chance. 10 plus 3 is 13. And then, good. Take away 2 is 11. So is that a plus or a minus 11 that I'm going to write? Plus. Okay. So all of that combines to be 4x plus 11. So set 1 is done. Questions? Okay. Do you guys think you need another slip for set 2 to be able to rip, or you think you can just handle combining like we did up here? Okay. Okay. So we're going to come around and give you set 2 if you didn't already have it, or set 3 if you're ready for it now, or set 4 if you're ready for it now. Yeah, we'll get you. Here's set 1, or sorry, set 2. Okay. You were needing set 2. I'll get you guys set 3 in a second. Y'all were all ahead. We'll get you the next ones. Come on in. Does anyone need set? Nope, y'all don't need it over here. Okay, raise your hand if you need set 3. Huh? You need set 2. Don't rip it, don't rip it, don't rip it. When you guys get the colored paper, don't rip these ones. I should have said that. I've done this lesson a few times now. You can, yeah. Okay. Set 3. Is anyone needing that one? Need set 2? Okay, that one paper. Y'all can, yep, work together. Huh? Oh, you can, yeah, I have set 2 up, but only that one. No one needs set 3? For what? There's set 4. Set 4. Oh, we all work together.
What do you mean? It's set 2. Wait, what do you mean? It's set 2 right now?
Huh?
Set
What is
3?
set 2? What is set 2?
That's what I just did.
Oh.
That was 7. It's my set 8.
So ignore the folded piece. Oh, sorry. Okay, guys, colored slips, do not rip them. Do not rip the colored slips. Okay. Did you need that one or no? Oh, no, you're at set 4. Okay. Just keep going since it's already ripped. Set 4.
Plus 16.
Okay. Oh, you do.
16, not
Oh,
15.
set 4 is where it gets a little more complicated. All right, and remember, they're all going to need the levels. I'm going to leave y'all with a set 3 because you're going to need this in a second. I know.
So we just had 4x. So what's 4x plus 1x to give us?
those are not like terms you actually combine.
Yeah, 5, right? So what do we write? How many x's do we have? 5x. That's it. You got it. So now, again, we have negative numbers. Do we want to start with negative numbers? No. So let's start with our positives. What's 3, 4, minus 4 is 0, and then minus 8. Get to our negative numbers, right? So 0 minus 8 is negative what? Negative 8. So that's exactly what you write next. Ooh, let's see how you did.
For set 4?
Let's go over set 3 first.
How are we doing on set 3?
Or what are you on? You're on set 2. Okay, so look, we're on set 2 right here. So how do we get set 3?
I bend it down.
Where's set 3 though?
Show me how you
Oh,
got
you
11
gave it to Miss
X's.
Pittman? Oh, okay, so she checked you off. So you are on set 4. All right, there you go.
Positive 4x. Danny, did you get that also for set 3? Okay. That would be the same as set 1, so we need to read. It is 4x. You got that part. Jalen, do you need help with set 2? You need help with set 2? You got 16 also? Oh, sorry.
10 minus 2x.
This shit is hard to
Which one you need?
So with 8x plus 1.
Minus 2 is, and then minus 1 more. It's 4x, good. Set 3 has 4x to start it off with. You got it, Darwin? When you added all those together, was it a negative 4 or a positive 4? All right, guys. So with most people got around to set 4. That's a good spot to be. Okay, we're just going to pause there for a moment, and we're going to transition to a different sort of piece to this. That little folded part that was you were told to just ignore that. Don't pay attention to it right now. Now I want you to pay attention to it. So without that equals sign, the piece that you folded back, okay, what is that thing called without an equal sign? Okay. Jakaya, you said that? Good. It's an expression. And what do we do with expressions? What were we just doing with them? We can combine like terms, which is simplify them, and we can also evaluate them. If I were to tell you, hey, let x be equal to 2, and then you could actually do some math afterwards, that's evaluating. Okay. But as soon as we flip this paper open, okay, we no longer have an expression. What does this turn into? An equation. Good. As soon as you have an equal sign, it becomes an equation. Okay, and so you have learned how to solve equations before, and so this first part is just going to be a little bit of review of how to solve a two-step equation. So I'm going to do set 1 up here as an example. You guys are going to use the half sheet that you have, but you're going to use the back where you're going to show work. If you have already been using the back to add up your numbers to when you're combining like terms, just let us know and we can give you a separate sheet of paper if you need some more space. Okay. But set 1, what did we learn that all of this combined to be? When we simplified it, look at set 1 for your answer sheet.
Right?
What
did
did all of that combined to be? It became 4x plus 11, yeah. But now the only new thing that I'm throwing at you is it's not just an expression anymore. All of that is going to be equal to 3. Okay, this is the first time this year that you've seen an equation coming at you, so I wanted to review a little bit. How do we solve equations? 4 times 1. Okay, well, we don't know what x is. The point of solving an equation is we're going to figure out what x is, right? Okay. Simone? Okay, so Simone already has it solved. Let's see. What's the very first thing y'all remember about solving an equation? It's not even really a step, but what do y'all all do? Draw the line down the equal sign. split it into its two halves, okay? And we need to maybe refresh our memory on inverse operations. The purpose of solving an equation is to isolate x.
Do 11 minus 4.
So remember, this is a variable term and that is a constant. Can we add those together?
You do 11 minus 3.
Okay.
And
So
then you bring the 4x down.
let's think about this x. What is being done to that x
What operation is that?
with the 4?
4 plus x, 4 minus x, 4 times x, right?
Okay. So we're taking this secret number. We don't know what number it is. That's the point of solving an equation. We're taking this secret number and we're multiplying it by 4. Okay. And after we multiply it by 4, what are we then doing to it? We're adding it with 11. And the result that we get is 3. So can you all think of that number right now? What times 4 plus 11 would give us 3? Any thought? It's kind of hard to do in your head, isn't it? 7? Okay, Darwin just said, isn't it a negative number? I would agree. Because the only way we're going to get a smaller number out of adding 11 to something, this has got to be negative. Okay. So let's reverse what we did to the number so that we are working backwards to get it back to where we started. How do we reverse adding 11? Right, subtract it. That's how you undo addition. The opposite of addition is subtraction. How do we undo multiplying? Division. Okay. Have you guys ever seen this before? A do-undo chart? Some teachers use it, some don't. This is just a good strategy for understanding how to solve an equation. So notice this is what happens to the variable. You have to go in order. And then to undo those things, you work backwards. So the first thing we're going to do to both sides of this equation is subtract 11, like Jakaya had said. So I'm going to switch colors. Subtract 11. Okay? And I have to do it on both sides. Why? Because an equation is a balance beam. Virtuoso says it balances it back out. You can't do something on one side of an equation and not do it to the other, right? So I like to draw that just to show that I'm going to a new step. 11 take away 11 is 0. That's why we did it. It goes away. Okay. What's 3 take away 11?
Negative 8.
Okay. I hear negative 8. I hear 10. 3 take away 11.
It's 8.
Is it positive or negative 8?
Negative.
Negative 8. Okay. So that's there. And then what's left over here? The 4x. Good. I'm just going to bring it down.
And then don't you divide that?
Okay. And then, right, to undo multiplication, we're going to divide. Divide by 4 on here and divide by 4 over here. 4 divided by 4 is 1. 4 divided by 4 is 1. So technically it's 1x, but do I have to write the 1 in front? No, it's just x on its own. And then what's negative 8 divided by 4? Negative 2. So does that make sense to us?
Yes.
Negative 2. If we were to take it and plug it back in up there, negative 2 times 4 is negative 8. Plus 11. What's negative 8 plus 11? 3. We did it right. That's how we know we have the solution. Okay. You've all done this before, two-step equation. What we want you to do now is you have set 2 and set 3 and set 4 potentially at your desk. I want you to unfold it and just take your simplified answer that you already have on your sheet, okay, and then solve that equation. Thank you for watching. I hope you enjoyed it.